Okay students, let us do question 5 of exercise 8.2. In this question it is given to us that a parallelogram ABCD and E is the midpoint of AE, means this and this are equal, and F is the midpoint of CD. Now what to prove? AF means this line and EC, this line, trisect the diagonal BD, that this and this line is dividing the diagonal BD into 3 equal parts. It means we have to prove DP is equal to PQ is equal to QB. This means BD will be trisected. So let us start the proof. We have given that AB is parallel to CD, and this means AE is also parallel to FC and AE is also equal to FC because AB is equal to CD. AE is parallel to FC because AB is parallel to DC. When full sides are parallel, then their parts are also parallel. And also AE is equal to FC. Why? Because AB is equal to CD. As it is a parallelogram, half of AB will be equal to half of CD. Their halves will be equal and they are the halves of AB as E is a midpoint, and they are also the half of DC as F is a midpoint. So their half is equal to the half, means AE is equal to FC. And one pair of opposite side is equal and parallel. This implies AECF is a parallelogram. Hence AECF is a parallelogram because one pair of opposite sides is equal and parallel, right? Now if AECF is a parallelogram, then it means its second pair is also parallel. So hence second pair, as it is a parallelogram, hence its second line is AF and EC. Hence AF will be also parallel to EC as it is a parallelogram, and this is a second pair of parallelogram. So this will also be parallel. Quality question number 1, because it is a very important, we have to use it. Now take triangle. In triangle this CDQ. In triangle CDQ, F is the midpoint of CD given. F is the midpoint of CD and this line will be parallel to this line. FP parallel to CQ. Why? Because from equation 1, AF is parallel to EC. AF is parallel to EC, then FP is also parallel to CQ. They are the parts of these lines and the parts are also parallel. Then what realize from this? Then by converse of midpoint theorem, the second point will be the converse of midpoint theorem. The conclusion is dash. See the diagram. F is the midpoint of CD. We are taking this triangle. F is the midpoint of CD. FP is parallel to this. Second side ke parallel hai. Then the third side, this P will be the midpoint of DQ. Right? P is the midpoint of DQ. Or what we can say, DP is equal to PQ. Quality question number 2. We have proved that this is a midpoint. Now similarly, now we will take the another triangle. See the diagram. We have taken this diagram. Now we will take this triangle. In triangle BAP. In triangle BAP. In triangle BAP, E is midpoint of AB given. See in the diagram, I am explaining you. In this triangle, what we will write? In this triangle, E is the midpoint of AB given, and this line is parallel to this line as the full lines are parallel to each other. Then in this triangle, by the converse of midpoint theorem, then this point will be the midpoint of this third line, and hence this and this will be equal. By this we will prove. But we will write E is midpoint of AB and AP. You can make the diagram first so that you can clear. AP is parallel to EQ. Why? Because AF is parallel to EC. When full lines are parallel from first equation, then this will be also parallel. And then by converse of midpoint theorem, it states that the line joining, that is Q, is midpoint of PB, because PB is the third line and Q will be the midpoint of this. This means, or Q is midpoint means PQ is equal to Q. We call it equation number 3. From 2 and 3, what you can conclude? Second and third equation. See the second and third equation. DP is equal to PQ and PQ is equal to QB. PQ is the same line in both, and that is equal to two different lines. It means they are also equal to each other, or all the three lines are equal to each other. DP is equal to PQ and PQ is equal to QB, and we have to prove this. See, we have written in the starting that we have to prove that this trisects the diagonal BD, means DP is equal to PQ is equal to QB. So hence we have proved our question. So we will write only one line now, hence proved, and in this way we can do this question.